In this episode of Woodlands on the Web, we're going to be looking at stoichiometric calculations. So I have some steps listed here and on your note sheet that you can use in case you're getting lost while trying to solve these problems. But honestly, if you have a strong understanding of factor label method and how to use units to tell you kind of where to go, then you honestly shouldn't even need these steps. You should be able to use the factor label method to tell you what to do. Okay, so I'm just showing you a very brief example here of how if you have the moles of one substance, then you can use this new mole ratio to switch to moles of a different substance in the same balanced chemical equation to find how many moles of that particular substance you would need. Okay, so let's start out with a kind of straightforward question. So first of all, we have 0.25 grams of aluminum foil. How many moles of aluminum and copper 2 chloride did we start with originally? So first of all, if you're just talking about the aluminum, we've done those already. That's a simple one-step mole conversion. So if you would, please go ahead and pause the video and see if you can determine how many moles of aluminum we used in this particular reaction. All right, if you're willing to check back your work and see how you did, you should be putting the grams of aluminum on the bottom, and you can switch from that to moles of aluminum using molar mass. Since this is an element, we're going to use the number off of the periodic table, which is 26.98, and the mole is alone. Okay, so this is just the molar mass of aluminum. When you plug that into your calculator, you should get 0.0093 moles of aluminum. Okay, notice your grams divide out, and that's what you're left with. Okay, the next question, though, is talking about a different substance entirely. And so when we do a factor label for that, we still have moles of aluminum on the top, so that means moles of aluminum will go on the bottom. In order to switch to copper 2 chloride, this is how we're going to use that mole ratio. Notice this is the only time that I have two different substances in the same conversion factor part of a train track. Okay, going back to the equation that we had from before, then we had a 2 in front of aluminum, so I'm going to put a 2 in there. And we had a 3 in front of the CuCl2, so I'm going to put a 3 there. When I multiply by that fraction, I get 0.014 moles of copper 2 chloride. Okay, again, notice that my moles of aluminum divides out, leaving me with the desired unit. Okay, so that's just how to use the mole ratio in general. All right, now, given the moles of aluminum we started with, I included the equation at the bottom for your reference. But then the question now is, how many grams of copper product should I have produced? So in the same token, or in the same kind of thinking, if I have moles of aluminum on the top, I'll put moles of aluminum on the bottom, but this time I'm going to switch to moles of copper. And because the question is asking me for grams, I can go from moles to mass of copper because that's what we use molar mass for. So I'll put moles of copper on the bottom since it's on the top currently, and then I can put grams of copper on the top. So again, always check your units before you go back and fill things in. So if I'm looking at my balanced equation, I've got a 2 in front of aluminum and a 3 in front of copper. 1 mole of copper is going to weigh 63.55 grams because that is its molar mass from the periodic table. When I work my problem, I get 0.89 grams of copper if I'm using significant figures. It comes out to be 0.8865 . Okay? So the last piece I want to show you is a mass-to-mass question. So most of our questions are mass-to-mass problems because we're going from grams of one thing to the other. So I would like us to do that together. So now at this point you are finished with this video unless you want to try it on your own first. But otherwise, thank you for watching and I hope this was helpful.